Hello again, my sweet students. I missed you. I wish you are studying well. Now, to make sure that you have been studying, let's make a quick revision on yesterday's lesson. We have been talking about different kind of forces. The main two kinds were contact force and non-contact force. Contact force like push, pull, and friction. Very good. And the non-contact force that we have is gravity. Excellent. Gravity is the only non-contact force we are going to discuss in grade 3. Now let's see what is gravity. Gravity is a non-contact force that pulls an object towards another object. And if we want to say this other object is what? Earth. Excellent. Both of them are correct. Our second definition is what is weight. Weight is the measure of the force of gravity on an object. Yes, we were using the spring scale to measure the weight of your lunch bags. Very nice. We have been using it and watching how the spring is stretching while we are hanging the lunch bags on it. Our third definition for today is what is mass. Mass is the amount of matter in an object. Like I gave you an example, as human beings we have bones, hair, skin, flesh, blood, bones, teeth, and all the other things that making our human body, they are our mass. They are the matter that is making the body mass. And we should never forget, mass should never change. Mass will never ever change. It will always remain the same. Very good. Now, the objective for today's lesson is the relation between gravity and distance. What do you think the relation between gravity and distance? Let's see. As you can see in the picture, Newton, of course, the scientist who discovered gravity, he was thinking, everything is pulling towards Earth. Why? Because of gravity. Okay. And where is gravity exactly? Is it on the surface of Earth or inside Earth or in the center of Earth? He was thinking a lot, and then he figured it out. He discovered that the distance and the gravity have a very strong relationship. That whenever the force of gravity between two objects depend on the distance between them. How? The distance between two objects increase, the force of gravity between them decrease. What does it mean? It means, for example, if you have a plane and it's going to fly high up in the sky, what do you think the gravity will be? Is it going to be very strong gravity or weak gravity? Actually, yes, it will be weak force of gravity. Why? Because he proved that the center of Earth is the strongest point of the gravity. So it's just like a magnet. Whenever we are moving away from the magnet, the strength of the force of attraction of the magnet is weaker. So exactly the same as the airplane. The airplane is high up in the sky. So gravity is so weak, it cannot reach it. It tries to reach it and pull it down, but it's getting weaker and weaker whenever the distance is getting bigger and bigger. So they are inversely proportional. Means what? One of them is going to increase, the other one is going to decrease. One of them is going to be more, which is more distance. The other part is going to be less, which is less force of gravity. So the force of gravity decreases as you go farther from the center of Earth. Gravity and distance. As you can see here, this is a mountaineer. The mountaineer, he is climbing the mountain away from the Earth, away from the surface of Earth. The force of gravity on the mountaineer is less on the top of the mountain than on a beach. If you think, if he's on a beach, this means that he is in the sea level and he is on the earth surface level, which has a high gravity, which has what? A high gravity. But he is now getting away from the Earth surface. He is going higher. The distance of him and the center of Earth or the surface of Earth is getting more and more. He is going away. So the force of gravity here, is it going to be strong force of gravity on the top of the mountain or small force of gravity? Yes, it will be a small force of gravity. Why? Because the distance is increasing. And what is the force of gravity is going to be? Decreasing. Very good, very good. Now, although the mountaineer weighs less on the top of the mountain, he will self that his weight is less. Why? Because there is not a lot of force of gravity pulling him down. It's weaker now. But what about the mass? Of course, the mass will remain the same at the top of the mountain and also at the bottom of the mountain. Why? Yes, because mass is the amount of matter in an object. He will still have all his bones, he will still have all his skin, his flesh, his blood. So nothing changed. His mass will never change. His mass will never change. Now, I need to explain something when I tell you that this object is at rest. What does it mean? Obviously, that it's not moving. As you can see in your left picture, we have a ball on a table. Is it moving? No, it's not. But does it mean that it's not moving, that there is no forces acting on it? No, yes, there is. Actually, two forces, as you can see in the arrows. One arrow is going down and one arrow is going up. Who's the smart one who is going to tell me what is the arrow going down? What is the force that is acting to pull it down, trying to pull it down? Yes, gravity, excellent. Gravity is trying to pull the ball down, so it has a force of gravity. What about the other force that is going the opposite? This is the force of the table. How? The force of the table, I just lifted it from the surface of Earth or from the ground to a higher place. So the table is keeping it up. So the table is pushing the ball up. And the gravity is pushing the ball down. But can we see any of these? No. And that's why we can see that the ball is not moving. Also in the other picture, let's do it again. What is the arrow coming from up to down? What is trying to pull the ball down? Yes, it's the gravity. And what is pushing the ball up? Yes, it's the force of the table. So, the ball has weight? Of course it does. Gravity is the force that pulls it down. And gravity is going to tell us the weight. So, the table will exert a force that pushes the ball up because this is not on the surface of Earth. This is another position. I change the position. Now, my smart students, I have two forces against each other in the direction, but the same or equal in the size. This means they cancel each other. They are not moving the ball. Yes? Huh? Do you remember? Yes, yes, this is combined forces. This is which kind? Balanced combined forces or unbalanced combined forces? Yes, of course it's balanced. Why? Because the two forces are equal in size, but also opposite in direction, but also opposite in direction. These forces are equal in size and opposite in direction, which we call it combined forces. Which kind of combined forces? Balanced combined forces. Very nice. Now, again, let's do it one more time. What's the force acting on the ball from the top, pushing it down? Gravity. What about the force it's pulling it or pushing it up towards the table? It's the table force. Now, one more time, we have the gravity trying to pull the ball down or acting the force from up to down, and the opposite force is the table. So, the forces are balanced. The net force here equal to 0, which means that the ball does not move. It didn't move, nothing moved it. So, they cancelled each other. The force of gravity cancelled the force of the table. But if I pushed it, like the hand you have it here, if I push the ball, do you think it will be balanced combined forces or unbalanced combined forces? Of course it will be unbalanced combined forces. Why? Because now we don't have equal in size or opposite in directions. They are too many directions and they are not same in size anymore. So if someone pushes the ball, the forces become unbalanced and the ball is going to move. Excellent. Of course it will move because I pushed it and I changed the balance between up and down. This is it for today. Hope you enjoyed our lesson. I really miss you. If you have any questions, please don't hesitate to contact me on Class Dojo. Hope to see you soon. I miss you all so much. Study well, please. Study well, my lovely students. See you tomorrow.